So LiDAR, or light detection and ranging, uses lasers to measure the elevation of things like the ground, forests, and even buildings. It's a lot like sonar, which uses sound waves to map things, or radar, which uses radio waves to map things, but a LiDAR system uses light, sent out from a laser. But aren't lasers used for stuff like, I don't know, scanning barcodes, making your favorite band look awesome, removing hair? Ew. Seriously, how does a LiDAR system use lasers to measure stuff? Now, just for the record, there are different ways to collect LiDAR data. From the ground, from an airplane, or even from space. Airborne LiDAR data are the most commonly available LiDAR data, and airborne LiDAR data will also be freely available through the National Ecological Observatory Network, or NEON, so we'll focus on that in this video. So to get how lasers are used to calculate height in airborne LiDAR, we need to understand the 4 parts of the system. First, the airplane contains the LiDAR unit itself, which uses a laser to scan the Earth from side to side as the plane flies. By the way, for you remote sensing geeks out there, the laser system uses either green or near-infrared light, because these wavelengths or types of light reflect strongly off of vegetation. The next component of a LiDAR system is a GPS receiver that tracks the altitude and XY location of the airplane. The GPS allows us to figure out where LiDAR reflections are on the ground. The third component of a LiDAR system is what's called an Inertial Measurement Unit, or IMU. Not to be confused with EMU, an IMU. The IMU tracks the tilt of the plane in the sky as it flies, which is important for accurate elevation calculations. Finally, the LiDAR system includes a computer. The computer records all of that important height information that the LiDAR collects as it scans the Earth's surface. No computer, no data. It's as simple as that. Now you may be wondering, how do the laser, the GPS, the IMU, and the computer all work together to get us these fantastically useful LiDAR datasets? Well, the laser in a LiDAR system scans the Earth, actively emitting light energy towards the ground. Now, before we go any further, let's get 2 key LiDAR terms associated with this emitted light energy out of the way. You know, so we can speak LiDAR and all. First, let's define the word pulse. A pulse simply refers to a burst of light energy that is emitted by the LiDAR system. And second, let's define the word return. Return refers to reflected light energy that has been recorded by the LiDAR sensor. So pulses of light energy travel to the ground and return back to the LiDAR sensor. Now we're speaking LiDAR. Now all of this pulse and return business is great, but speaking the language doesn't give us height. To get height, the LiDAR system records the time that it takes for the light energy to travel to the ground and back. The system then uses the speed of light to calculate the distance between the top of that object and the plane. So let's break down what this distance calculation looks like. You take travel time, multiplied by the speed of light, divided by 2 since the light traveled to the ground and back. This calculation gives us how far the light actually traveled to the ground. So using this math, we know the distance between the plane and the ground. But we're not done just yet. How do we figure out the actual elevation of the ground? To figure out ground elevation, we take the plane's altitude, calculated using that GPS receiver. And then we subtract the distance that the light traveled to the ground. And that covers the basics of how a LiDAR system uses lasers to measure height. So now we've got the basics down, but there are 2 more things that a LiDAR system has to consider when calculating height. First, the plane rocks a bit in the sky as it flies due to turbulence in the air. These movements are recorded by the Inertial Measurement Unit, or IMU. No, not EMU, IMU, so that they can be accounted for when height values are calculated for each LiDAR return. And also, an airborne system scans the Earth from side to side to cover a larger area on the ground when flying. So while some light pulses travel vertically from the plane to the ground, or directly at nadir if we're still talking LiDAR lingo here, most pulses leave the plane at an angle or off nadir. So the system also needs to account for pulse angle when it calculates elevation. So let's put this all together one last time. The LiDAR system emits pulses of light energy towards the ground using a laser. It then records the time it takes for the pulse to travel to the ground and return back to the sensor. It converts this time to distance using the speed of light. The system then uses the plane's altitude, tilt, and the angle of the pulse to calculate elevation. It also uses a GPS receiver to calculate the object's location on the ground. All of this information is recorded on that handy-dandy computer, also mounted on the airplane. And that, my friends, is how a LiDAR system works. Now, there is one more component of a LiDAR system that makes it so useful. A pulse of light doesn't just reflect off of one thing, like the top of a tree, and yield one return. Sometimes a LiDAR pulse travels through things, like the gaps between tree branches and leaves. Think about standing on the forest floor and watching the sunlight filter through the tops of the trees, making the leaves and branches glow. So light energy that passes through the canopy reflects off of the branches and leaves within the canopy. This ability of a LiDAR system to travel through and record information starting from the top of the canopy, through the canopy and all the way to the ground makes LiDAR systems unique and highly valuable to scientists studying trees. These returns from within the canopy tell us more about what's happening inside the forest, or the forest structure. For example, they can tell us about the shape of the trees, or the density of the leaves on the trees. They can sometimes even be used to estimate whether there's shrubs below the trees on the forest floor. But we'll save that topic